All right, we're going to be working on factoring today. If you'd like, pause the video to start, see where you end up. I'm going to show the answer key here right now. All right, see what you can come up with. I'm not going to do all of them, but I will certainly do a good number to get you all started. All right, so first off, we have number 1, which we are actually going to take a look as we're tackling each and every problem. We're going to be looking at a GCF, the greatest common factor. So looking at these 3 terms, do they have anything in common? No, I mean, 4 and 12, they're both negative. Yes, those have in common, but notice that the third term doesn't have a GCF with that. So there's no GCF. But even better, if your leading coefficient, that's the one attached to the highest degree here. So each of these, your highest degree of this one is 6. Each of them are going to have a coefficient. Now, if it's not showing, it's going to be a 1. If it is showing, then that's going to be its value. So with this being a coefficient of 1, this is your simple factoring. This is the quickest and easiest factoring method that we have. So if that's the case, we're looking at factors of C. So your quadratics all have the form ax squared plus bx plus c. So we're looking at factors of C, your constant. So 1 and 12, 2 and 6, 3 and 4. So factors are what multiply into that value. So of these factors, 1, 12, 2 times 6, 3 times 4, what can add or subtract to this middle term b? So your middle term is -4. So which factor can multiply to -4? Not multiply, add or subtract. 2 and 6 can add and subtract to 4. And we want, let's see, if we're looking at 2 and 6, we want to get out a -4. So the bigger number is going to get the sign. So if this is negative, the bigger of the 2 values is going to get the sign. So -6 plus 2 will get -4. Now there's only 4 different combinations. You can do both adding to be 8, both subtracting to be -8. You can switch one around to be negative. So you only have 4 combinations to get it correct. Now we want a -4, so that's how this one will work itself out. Now we always want to check that our signs are correct even when we multiply. So we should get a -12, which we have right here. So the signs on this is correct. They produce a -4 when added and subtracted, and when multiplied, we get a -12. So once we find your factors and their signs, we get to put them into parentheses. X plus 2 and x minus 2. Now, the best way to check if we did it correctly is to FOIL it back out, which I'll allow you guys to FOIL out to see what we get. So let's try it again with 2. So again, we're looking for factors of C. So if we're looking for, actually before that, a GCF, do any of these factors have something in common? No, they don't all have a unique thing in common. So we can go ahead and do what we did before. So factors of 72, we have 1 and 72 that work. And if you already know some of your other factors, oops, battery's running low, that's great. Otherwise, we can think, okay, 2 times 36. We're trying to get ones that get to 17. We can try dividing by 4. 4 times 18. We can try not by 5. Let's see, by 6. 6 and 12. Getting a little bit closer to that 17 mark. And let's try 8 and 9, right? 72, 8, and 9. So of all of your factors, what can make a 17? Well, 8 and 9 can make a 17. 8 and 9. How can they make a 17? Well, this is a positive 17. So they both have to add together to make positive 17. And if we multiply them together, Both positives will make a 72, a positive 72. So once you find what works, we're going to insert them in. And I just noticed I put X's here. I have a very bad habit of just using X. I apologize. So the R's being A, we have A plus 8 and A plus 9. Let's see, a couple others for you guys to practice on. I don't see any here yet. Okay, let's move on to 3. So we have 6y squared minus 6y minus 12. So again, before we get started with your factoring, let's go ahead and see, do they have anything in common? Well, notice that they have 6's in common. So we have 6 and 1, 6 and 1. 6 times 2 can make 12. So what we can take out is a 6. Now, do they have anything else in common? Unfortunately, no. Had this had a y in common, we could also take it out. But unfortunately, it doesn't have a y in common. So what we leave behind is 1y squared minus 1y minus not a 12, but a 2. So now that 6 is going to act as a GCF. So that just kind of follows us throughout. So now we get to look at 2. So factors of 2, 1 and 2. Now how can we structure 1 and 2 to get us to a negative 1? The bigger number gets the sign, so negative 2, positive 1. And if we were to multiply them back together, we get a negative 12. Not a 12, negative 2, which is what we needed from here. So you found your signs. You found what worked. So they get to go right in. X plus 1 and X minus 2. Again, FOIL to check your answers. Let's try it again with 4. So looking at this one, we have 7y6. So we have 7, 14, and 168. So 7 and 14 have a 7 in common. And if you haven't done 168 yet, you can kind of tell, okay, well, let's try to divide it by 7. So 168 divided by 7 is 24. Let's see, 7 times 2, 7 times 1. So at the very least, they all have a 7 in common. So we're going to factor out a 7 from each. Now, what else do they have in common? Well, they have y's in common. They have 4 y's over here. They have 5 over here. And they have 6 over here. So at most, how many do they have? Well, they have 4 that you can highlight in common, which means we're taking out y to the 4th. So that means what's left over. So in this first term, there's 1 and 2 y's, so 1y squared, plus from this term, we have a 2 and a y. And from your remaining term, we have minus a 24. So now we're looking at factors of 24. So factors of negative 24, 1 and 24, 2 and 12, 3 and 8, 4 and 6, that can then get us to a positive 2. So of those, 4 and 6 can get us to a 2. So 4, 6, to get a positive 2, the bigger number gets the sign, so plus 6 minus 4. And if you were to multiply them together, they come up with a negative 24. So that works. So you found the factors and their signs. So you have 7y to the 4th. Then you have you have y minus 4 and y plus 6. And again, your GCF, we pulled out is just going to trail us. And I, again, just realized that these aren't y's. These need to be y's. There you go. All right, let's try it again with 6. Oops. So what do they have in common, if anything? Unfortunately, they don't have anything in common, but they do have multiple variables going on, which isn't going to be a big deal for us. But right now, just kind of pretend that this n isn't there and kind of proceed as normal. We're going to bring that n in at the very end. So factors of 4, 1 and 4, 2 and 2, that can get us to a -3. Well, that's going to be 1 and 4. So 1 and 4 to get us to a -3. The bigger number gets the sign, so it's negative, positive. So 1 minus 4 is -3. And when you multiply them back together, that remains to be the -4. So you found your signs. So when we go to insert it, we have m plus 1. And this is where the n comes into play. This is when we can actually put in the n value. Doing it again over here, we have m minus 4n. All right, let's do number 8. Actually, let's do some special cases. We're going to take a look at 12, 24. Then we'll do 11. No, actually, I backtrack. Let's do, trying to find some good ones. A good one after doing some of these would be 13. Trying to think on some other ones. Okay. Let's take a look at 14. We'll do 14. All right, 14 is slightly different. So 14 is slightly different from what we have been doing. And the reason for that is after you check for a GCF, which unfortunately there is none, what we are looking at is now having a leading coefficient that is other than 1. So now what this is going to do is this is going to make it to be quote unquote complex factoring. So complex factoring meaning we just have a few extra steps than what we've done before. Actually, no. Let's take a look at number 8. All right, we're looking at number 8. Now, the difference between number 8 and what we had been doing is that we now have 4 terms. Now, we sure as heck could kind of backtrack and combine these to make a z. However, what I want to point out is when we go into something called complex factoring, we're going to want this skill. So what they've done for us is they are breaking up this middle term as its factors of -6z and 7z. So all they are doing, instead of just saying this is really a positive z, they rewrote their middle term. Now, when you have 4 terms, what we can try is factor by grouping. So you're going to group the first 2 and group the last 2. And we're going to look for a GCF. A GCF being what they have in common from these 2. So this has a 1 and 2 z's. This one has a 1, a 6, and 1 z. So we're going to highlight what they have in common, which is just one of these z's, leaving behind 1 z minus 6. And if you don't want to express the 1, that's all right. So we have z minus 6. Now let's do it again on the other one. So you have 1 and 7 and a z. And you have, let's see, negative, or you have a negative on the outside, 6 and a 7. So they have a 7 in common. And even better, we're going to pull out a positive 7. If they're both negative, we pull out a negative. If your leading one is negative, then we can pull out the negative as well. But because this one is positive, we're just going to say plus 7. Leaving behind what is not highlighted, 1 z minus 6. Now, if we did this step correctly, your parentheses should match. In our case, our parentheses matches, which means that we are going to factor out this z minus 6 from the term on the outside. So we have z minus 6 and z plus 7. Factored that z minus 6, you're just writing one of them, and then what's left behind was the z plus 7. So this is factor by grouping when you have 4 terms. So again, if you wanted to combine them and do simple factoring there, that's perfectly fine. Now let's try it again with 17. So looking at a GCF of all of them, unfortunately, there's no GCF. So let's do factor by grouping. So factoring or grouping them first 2 and last 2. So looking at your first 2, this has 2x, this has 1. Oops. So we're only going to factor out one of these x's. We have x minus 4 is left behind. Doing the same to the other, we have negative 1 and 5. We have 5 and 4. So let's take out a 5. And we have a negative to start, so we're also going to take out a negative as well. So we're going to take out a negative 5 to leave behind an x sign change minus 4. Now let's say you didn't take out the negative, so you're left with negative x plus 4. Notice how close that leaves your parentheses. Now if it's that close, take out a negative and see if it works. So now let's go ahead and factor out this x minus 4 because that's what they have in common. We have an x minus 4 in common and leaving behind your x minus 5. And that's your final answer. Now let's try that skill and pair it with what we have in 14. Now, first, after you see a GCF, if you have one, you can pull it out. In our case, 14 does not have a GCF, so we have to leave it. So what we are going to do is combine the skill that we just learned, the factor by grouping, along with your simple factoring ways. Now, this one is not simple factoring because your leading coefficient is no longer a 1 or a negative 1. This is now a positive 8. So to start, we're going to do something called the AC grouping method. your AC grouping method, and keep in mind your structure of these is ax squared plus bx plus c. So your structure, we have A is equal to 8, B is -10, and C is -3. So AC grouping says we're going to multiply A times C. 8 times -3 makes -24. So then looking at factors of 24, we're looking at, okay, how do these factors make up a -10? While also keeping your -24. Well, you could be really tempted to say, okay, -2, not -2. -4 minus 6 makes a -10. But when you multiply those two negatives together, that makes a +24, which does not work. So that just means there's another pair that works. 2 and 12. 2 and 12 will work to make a -10 as long as you have -12 plus 2. Multiplying them back together will get you to a positive or a -24. So be super careful. Sometimes there's a few ones that look very promising, but when you do both the addition and the multiplication, it may no longer work. Now, what we're going to do, instead of putting them into parentheses, we're going to rewrite your middle term. Your middle term being with a k, we now have plus 2k minus 12k minus 3. So we are just rewriting this -10k as your factors. Now you'll notice you have 4 terms, so we can go ahead and group. And the order in which you write your middle term k's doesn't matter as long as you just keep what's positive and what's negative. So now pulling out a GCF, we can pull out a 2k from both, leaving behind 4k plus 1, your placeholder of 1. Notice that on your second one, you can pull out a negative from both and a 3, leaving behind k plus 1. 4k, I'm so sorry, plus 1. Since your parentheses match, you did it correctly. If they don't match, there's one of two things. Either it's not factorable, which the ones I'm going to give you are always factorable, or you did it incorrectly, so human error. So we can make a 4k plus 1 and a 2k minus 3. Let's try it again with number 20. So looking for a GCF, do you have one? No. So let's do 9, 12, and -5. So A times C is 9 times -5, which we got -45. So factors of 45. We have 9. Let's see, 45 divided by 3, or well, I'll start at the beginning. It's not divisible by 2 because it's odd. So 3 times 15 can get you to 45. It's not divisible by 4, 5, and 9. So of your factors, what can get you to a positive 12? Well, 3 and 15 can get you to 12. Where do I want to write that? So 3 and 15, as long as you have a positive 15 and a -3, when you multiply them back together, they get to be 45 or a -45. So we are rewriting your middle term of 12y to be -3y plus 15y minus 5. Again, order doesn't matter. You're just rewriting these in its terms. You have 4 terms, so factor by grouping. You can pull out 3y to make 3y minus 1. And you're pulling out a positive 5 to make 3y minus 1. You have 2 of the same parentheses, so that gets factored out. 3y minus 1, and you're left with 3y and a 5. And there you go. Let's try one more. Let's try 23. All right, no GCF. So again, we're just going to pull out A, B, and C. 6, -5, -4. A times C is 6 times -4 to make -24. Factors of 24 that can get you to a 5. We have 3 and 8 as long as we have a -8, +3 to make a -5, and multiplying them back together, we get -24. So that works. So we get 6y squared plus 3y minus 8y minus 4. Factor by grouping, group the first two and the last two. What they have in common, they have a 3 and a y in common, leaving behind a 2y plus 1. They both have a negative in common, so we're going to factor out a negative along with a 4 to leave behind a 2y, sign change, plus 1. We have 2y plus 1 and 3y minus 4. You should always be looking for a GCF at the beginning. If you don't hit it at the beginning, always check that your parentheses, they don't have anything in common. It does happen quite frequently. So after doing those, I would suggest doing 25, 19, let's see, 10, 19, or 9, 19. Again, just being on the hunt for a GCF. Now the last ones we're going to do, those are going to be special ones. We'll only do a few of them. So let's look at 11, 22, 15, 16, 24. Let's start easy. Let's look at 24. So 24 is special because we have the difference of squares. So the difference of squares is when your first term and your last term, and there's only 2 terms, are perfect squares. So a number times itself is a perfect square. A number times itself 3 times is a perfect cube. So we can go ahead and rewrite this to be m squared. And what times itself makes 81? What's 9 squared? And even better, the way to recognize as well that these are a difference of squares. The difference meaning subtraction. So as long as they are both subtracted, there's 2 terms that are both showing a square. So we can write 2m's, because m squares 2m's, and 2 9's. And what they need in order to not have a middle term is to alternate your signs. Make one positive and one negative. M plus 9 and m minus 9. Let's try it again with, let's do 16. So do your values have a GCF? Well, they both have a 50 in common. So they have a 50 in common, so we can factor out a 50 to make z squared minus 2. Now, is this a perfect square situation? So while it looks promising, there's a subtraction sign, there's 2 terms, your first term is a perfect square, but is 2 a perfect square? Well, 2 only has 1 times 2 as a factor, right? It's not multiplied by itself to get to 4. So unfortunately, this is as far as it goes. So this one is not a perfect square. But let's take a look at 15. Now with your 15, right, again, you might think this might not be a perfect square, but 16 is a perfect square. What number times itself makes 16? Well, 16, 4 times itself makes 16. And the 4 up here, right, is actually a perfect square itself. You can just say this is really x squared, all squared, with the properties of exponents. So really, when we go to write it out, we have 2x squares and we have 2 4s. Again, alternating their signs, one positive and one negative, to make x squared plus 4 and x squared minus 4. Now, are we done with this version? We're not. Looking at one of these two is another perfect square. X squared minus 2 squared. Writing out 2 and 2, one positive, one negative. So your last, your final response should be as such. Now there's no such thing as the sum of squares, so this one does not get broken up because there's an addition sign. Now last up, we are going to do cubes, so the perfect cube. Now I'm going to rewrite this one below. We have t cubed minus 27. Again, showing that it's a perfect cube. You can have the sum and difference. That is okay for these ones. So whether it's a positive or a negative sign in the middle, doesn't matter. We have t cubed plus, and what's the cube of 27? One number times itself 3 times gets you to 27. Well, that would be 3 cubed. So just like last time, let's write 3 of everything. And unfortunately, we can't just alternate your signs because we are working with cubes. So instead, let's take the first 2 and let's have its own parentheses. So these first 2 get its own parentheses, t and 3. Ignore the signs for now. Open up a bigger parentheses. Now the last one, we're going to square these 2 values and put it on either end. So we should have t squared and 3 squared, which is equal to 9, right there. Now the middle one is special. We are going to multiply these together in the middle term. So we should have 3 times t, which is just 3t. Now what is missing from your answer? It's your signs. So your acronym is SOAP. It means the same sign as what you start with. So we started with a positive, we're positive. We then switch to the opposite sign. So opposite of positive is negative. And the last one is always positive. And there you go. Now this comes directly from the equation for the difference of cubes. This is kind of a breakdown of how to get to that equation itself. Your equation just being a plus b, a squared a squared minus ab plus b squared. Where a and b are itself here. This would be considered a. This would be considered b. Let's have you try it again with 22. Let's actually, let's see. 22 is not a difference of cubes. I don't have another perfect cube for you. Let's have you try another one. Let's do 64t cubed minus 27. So 64 is a perfect cube of 4. And 27 we already did. So we really have 4t and 3. So the first one we get to put into its own parentheses, 4t and 3. Opening up a new parentheses. The last ones we're going to square and put on either end. So we have 16t squared and 9 squared. And your middle ones we're going to multiply. Oops, that's not your middle one. We're going to multiply 4t by 3t. So 4 times 3 is 12 times t. And then your acronym of SOAP, same, opposite, always positive. So hopefully that clarifies how to factor. Again, you're going to show all of these answers if you need it. So good luck with your factoring.